Hi there, amazing people, students, lovers of chemistry out there. I'm super excited to be here with you today on this episode of Question for the Day. And on today's episode, we're going to be dealing with a question that deals with the solubility of a substance. Now, the question on the screen starts off by saying at 25 degrees Celsius, 36 grams of potassium chloride, KCl, can dissolve in 100 grams of water. Calculate the solubility of KCl in moles per dm³ at 25 degrees Celsius. So first things first, let's define what solubility means and then let's apply it to the question we want to solve. Solubility is simply the amount of a substance that can be dissolved in a solvent. A solvent is simply a substance that dissolves another substance. So for instance, now let's say you have a glass of water like this, and then you have some salt poured inside that glass of water. You'd agree with me that after a period of time, that salt that you poured into that glass of water will not be seen anymore. Why? Because it has dissolved. Now, the salt is called the solute because it is the one that is dissolved, and the water is called the solvent. So solubility is simply defined as the amount of solute that can be dissolved in a particular amount of solvent. And in this case, they want us to determine the amount of or the level of solubility in moles per dm³. So they are asking us that how many moles of KCl can be dissolved in 1 dm³ of water. That is what the question is simply asking us to do. So now that said, let's go ahead and solve this question step by step. In this case, they want us to determine solubility S in moles per dm³. So first things first, let's convert our values into number of moles. The amount of solute, which is potassium chloride, that we were given is 36 grams. And then we're given the amount of water as 100 grams. So let's go ahead and determine the values. First of all, number of moles is equal to the mass of a substance divided by the molar mass. The mass of potassium chloride we were given was 36 grams. So we divide this by the molar mass of potassium chloride. Now they have given us the molar mass of potassium chloride to be 74.5. If you're wondering how we arrived at that, the formula for potassium chloride is KCl. So we arrived at that by adding the atomic mass of potassium plus the atomic mass of chlorine. The atomic mass of potassium is 39.0983, as you can see denoted here. And the mass of chlorine, the atomic mass of chlorine is 35.4527. So when we added the two of them, approximately it gave us 74.5. So we have 36 divided by 74.5. Now if we do a quick math and we say 36 divided by 74.5, we arrive at 0.483 moles of potassium chloride. Now we have the number of moles of potassium chloride that was involved in the reaction. Remember, they are asking us to calculate the solubility as number of moles contained in 1 dm³ of water. Now at this point, what we want to do is to find the volume of water. Alright, so we're given the amount of water in grams, so we want to convert this from grams to volume. And the formula for volume says volume V is equal to the mass of a substance divided by the density of that substance. The mass of water here was 100 grams. The density of water is 1 grams per mil or 1 grams per cm³, whichever one you choose. So when we do the division, the volume of water now becomes 100 cm cube. You can use 100 cm cube, or you can say 100 mils, whichever one you choose. So now we have the volume of water and we have the number of moles of potassium chloride. Now, there is one little conversion we also need to do. They said we should calculate the solubility in moles per dm cube. The volume of water we have here is in cm cube, so we need to convert it from cm cube into dm cube. So how do we do that? When you want to convert from cm cube to dm cube, you simply divide by 1000. So 100 cm cube will be equal to 100 divided by 1000 dm cube. When we do this math, we end up having volume is equal to 0.1 dm cube. Now at this point, we have the number of moles of the solute, which is 0.483, and we have the volume, which is 0.1 dm cube. So now we can calculate the solubility. Remember, solubility is the number of moles of a substance contained in 1 dm cube of the solvent. So if 0.483 moles of KCl is contained in 0.1 dm cube of water, how many moles, x moles, will now be contained in 1 dm cube of water? Because solubility is the number of moles contained in 1 dm cube. At this point, we can cross multiply. When we cross multiply, we have 0.483 is equal to 0.1x. So x now becomes 0.483 divided by 0.1. Doing a bit of math reveals to us that 0.483 divided by 0.1 gives us 4.83. This is the solubility measured in moles per dm cube. I'm sure you saw how we carried out each of the steps. So first things first, we converted these 36 grams to number of moles, and we converted this 100 grams into volume in dm cube. And then we used the relatable formula. If 0.483 moles is contained in 0.1 dm cube of water, then how many moles will be contained in 1 dm cube? So we cross multiplied and we found it to be 4.83. That is the solubility of potassium chloride in this question. I'm sure you enjoyed every bit of this.